Hello everyone. In this section today, I'll be talking about trig functions on acute and non-acute angles. So let's start with what it means by acute angles. As you all know, acute angle is the angle that less than 90 degrees. So we're going to start with a right triangle. Okay? Let's call this triangle A, B, C. So the hypotenuse is denoted by little c. This side is little a, this side is little b. And let's call this angle theta. Okay, and obviously the angle C is 90 degrees. So the angle A is an acute angle for sure, because you know the sum of three angles is going to be equal to 180. This is 90. So this angle theta is going to be less than 90. Let's call this one theta. How about alpha? And the angle alpha right there, of course, also less than 90 degrees, also another acute angle. Okay? So now we're going to talk about the relationship between alpha and beta in this triangle. So let's start with alpha. We know that the angle alpha plus the angle theta is going to be equal to 90 degrees, because the sum of the three angles is equal to 180, and this is 90 degrees for the angle C already. So the other two angles sum up going to be equal to 90 degrees. Another word, alpha is going to be equal to 90 degrees minus theta. By the way, it's just our tradition to use Greek letters to denote the angles of any figures, such as triangle. Okay, so let's start with the trig function of the angle theta. Let's start with sine theta. Sine theta, oh, by the way, if you got alpha equal to 90 minus theta, it's the same thing as theta going to be equal to 90 degrees minus alpha. I think that's just so obvious, so I wrote one, but you can know both. Okay? Sine theta, which we learned previously, sine is opposite over hypotenuse. So this is equal to A over C. But take a look at the angle alpha. If you take A over C, it is no more than the cosine of angle alpha, right? Because cosine is adjacent over hypotenuse. See, A here is the opposite side for the angle A, but it is at the same time the adjacent side for the angle B. So this is equal to cosine of alpha. In other words, this is equal to cosine of 90 degrees minus theta. Okay, sine of theta is opposite over hypotenuse, A over C. But when we look at the angle B, it becomes adjacent over hypotenuse, which is cosine of alpha. And we know that alpha is 90 degrees minus theta. So we have this. So we have our first formula showing the relationship between sine and cosine of the complementary angles. Sine theta equal to cosine of 90 degrees minus theta. Alright? And that will help you to solve quite a number of problems in your homework if you know, say, cosine of 50 degrees, for sure it's going to be equal to sine of 40 degrees, because 40 degrees plus 50 degrees is equal to 90 degrees. Alright? Let me double check on the word, make sure that I say it right. Yep. It's got complementary angles, right? Similarly, what if we talk about tangent and cotangent? Of course, sine theta equal to cosine of 90 degrees minus theta. You can do, say, the other way around. Sine of alpha is going to be equal to cosine of 90 degrees minus alpha. It's going to be the same thing. Okay? So our first formula. Sine of angle is going to be equal to cosine of the complementary angles. What about tangent and cotangent? let's talk about tangent of theta. Tangent of theta, and as we learned before, in the right triangle, tangent is opposite over adjacent, so A over B. Okay? Now, look at angle alpha right here. What is A over B? A over B is adjacent over opposite. And we know that adjacent over opposite is cotangent. So tangent of theta is going to be equal to cotangent of alpha, which is, now alpha is 90 degrees minus theta. So this is cotangent of 90 degrees minus theta. We've got another formula. Say what? Tangent of theta equal to cotangent of 90 degrees minus theta. Another word in general, whenever you know tangent of an angle, then you know cotangent of the complementaries of that angle. Okay, so say tangent of 35 degree will be equal to cotangent of 90 minus 35 is was that 55 degree? Yes. Okay. So you know one, you know two. And secant and cosecant work the same way. You know that secant is the reciprocal of cosine and cosecant reciprocal of sine. So pretty much I talk about sine and cosine. You just flip it over, you have secant and cosecant. Okay? Let me look at an example in the book. Okay. So we have this example. Example. Solve for x, and we have sine of 2x plus 15 degree equal to cosine of x plus say 45 degree. Okay. And let's assume that all the angles we're talking about are acute angles, so we don't talk about the coterminal yet, because you know what, when you go entire 360 degree, we're going to come back to the same sine and cosine. So put in here all acute angle. I'm just trying to show the relationship. So you see that sine of an angle equal to cosine of an angle. According to what we learned before, the sum of the two angles got to be equal to 90 degrees because they're complementary. Okay, so what? 2x plus 15 going to be equal to x plus 45. Okay, and we simplify, subtract the x both sides. We got x, and subtract the 15 on both sides. Subtract the x on both sides. Subtract the 15 on both sides. We got x equal to 30 degree. So look at it. 30 times 2 is 60 plus 15 is 75. Right? 30 plus 45 cents. Is that right? Oh, I make a mistake in here. It's not equal. Let me take it back. Sorry. Complementary. It means what? Add up. Equal to 90 degrees. Just kidding. Alright? So let's add up 90 degrees. No wonder it's not correct. Okay? Forget it. Go back to here. Add up equal to 90 degrees. So let's combine the right term. That's better. 3x plus 2x plus x, 3x. 15 plus 45 is 60. Now it looks right. Equal to 90 degrees. So you subtract the 60 on both sides. We have 3x is equal to 30 degrees. Yep. So x is equal to 10. Now it's right. 10 for x. 10 times 2 is 20, plus 15 is 35. Is that right? 10 plus 45 is 55. So 35, sine of 35 equal to cosine of 55. Now that is right. I apologize, guys. I make a mistake on it. Lucky I plugged in the jack, so fix it on time. Alright, this is a type of problem in this section. And let me look at the exercises. Pretty much problems in this section 2.1, you deal with the complementary angles. Okay. Now, let's move on to the next section, 2.2. Instead of talking about trig function on the acute angles, we extend the concept to trig function on non-acute angles. And what do we mean by non-acute? Those angles that's bigger than 90 degrees. Could be on the second quadrant, the quadrant number 2, on the quadrant number 3, or quadrant number 4. So we're going to put that triangle into the xy coordinate. Okay. This is the angle. Theta. Triangle ABC. Now I have B right here. The point B is right here. And this is the angle. Oh, I have to draw straight. I have the angle this way, obtuse angle in this case. The point B is on quadrant number 2. So how do we deal with trig function in here? Remember the word coterminal. Means that we try to convert or bring it back to the acute angle associated with that given angle in this particular problem. So if I have the angle right here, say 120 degrees, the coterminal angle associated with 120 is going to be this angle right here, 60 degrees. Okay? And you're going to work with the trig function on 60 degrees. However, there's one thing changed. Because point P on the second quadrant, you see what? Cosine, the x value will be the negative number. Sine value, the y value will be a positive number. So pretty much everything's the same whenever you have, this is 120 degrees, right? So sine of 120 degrees is still positive. Okay? It's positive. Positive. I don't know what it is yet. Just assume I don't know. But when you have cosine of 120 degrees, it's going to be a negative number. Okay? Because it's on the second quadrant. Cosine is right here for the x value. And you know a sine of 120 degrees will be equal to sine of 60 degrees. So cosine of 120 degrees will be equal to negative cosine of 60 degrees. Because cosine of 60 degrees is a positive number. You put a negative sign in front, you got cosine of 180, 120. And the sign is going to be the same because this is on second quadrant. That was the idea. So pretty much whenever you guys have a non-acute angle, you try to find a coterminal. That's the key. And you work with the acute angle and then match up with the sign. Could be positive, could be negative. So another example. What if I have an angle, this way then. Y-axis right here, x-axis right here. If I have the angle of 200 degrees, this way, my point B is right here. And this angle from here to here is 200 degrees. So how do you find trig function for angle 200 degrees? Start with the sine and cosine, the other things the same. Sine of 200 degrees. Instead of working directly with 200 degrees, we're going to find the coterminal angle of 200 degrees. So this is the coterminal angle right here, this small one right here. You know how much that is? It's going to be 20 degrees. You guys see why this is 20? Because this from here to here is 180 at another 20. So it's going to be equal to sine of 20 degrees. But it's not going to be positive. You see why? Because 200 degrees on quadrant number 3. Even though the value is the same, the magnitude is the same, but the sign is going to be opposite. So if this is, say, 0.4, then this one is going to be negative 0.4. Okay? And similarly, cosine of 200 degrees will be equal to negative cosine of 20 degrees. Because they're both negative. Same idea. what if this time I have an angle on quadrant number 4? This is my point B, and this is my angle all the way here. And this angle is 320 degrees. And you know what this angle equal to? This angle is going to be 40 degrees. You guys see why? Because the entire thing is going to be 360 for a complete circle. We got 320 already, plus 40 is going to be 360. Since point B is on quadrant number 4, you know the cosine will be positive, x is positive, okay? But sine will be negative. Can wipe out the cosine. All right. So sine of 320 degrees gonna be equal to sine of 40 degrees with the minus in front, and then cosine of 320 degrees will be equal to cosine of 40 degrees. With this sign, we do not need the negative sign in front because you know that those two angles will be the same value for trig function. They're both positive. All right. Pretty much, this is everything about 2.1 and 2.2. To graph up those two sections, let me make a table of some typical trig function of some special angles that you guys going to use a lot. So it's going to be good. I would say this way it's going to be better if you can somehow memorize them. Okay, so let me write down. Angle theta, we have sine, cosine, tangent. Let's make 3, okay? And then you can figure out the other one. Start with, how about 0, 30 degree, 45 degree, 60 degree, 90 degree, pretty much, it's good. Sine of 0 is 0. I'll just throw out the numbers, and then eventually I claim that when you guys work enough with those seven will become pocket notes. And then for 30 degrees, sine of 30 degrees is 1/2. 45 degrees, square root 2 over 2. 60 degrees is root 3 over 2. And 90 degrees, this is going to be 1. And cosine, right down here, more room to write. Cosine of 0 is 1. Just right backward. Gonna be it. Root 3 over 2, root 2 over 2, 1/2, and 0. And tangent is sine over cosine. So this is 0. This is 1 over root 3. Well, let's write it this way. Root 3 over 3. We try to rationalize the denominator. And this one is 45 degrees. Tangent is 1. And then what? Sine over cosine in here is going to be root 3, and this is undefined. Okay, tangent of 90 degrees undefined. Now, with that table, what if, because I claim that most of the time you guys are going to work with those angles. So if you have something like calculate sine of 135 degrees, you see that this is a non-acute angle, right? It's bigger than 90 degrees. So you try to find the coterminal, this angle. 180 minus 135 is 45. So you're talking about sine of 45 degrees. Question: would that be a positive sign or negative sign in front? And I claim this sign is going to be a positive sign. Why? Because the angle 135 is the obtuse angle. It's on the second quadrant. It's right here. It's the point. This is the angle 135. All right. So sine of 135 is still positive as sine 45. What about cosine of 135 degrees? And now we still bring it back to the acute angles that we're talking about. Cosine of 45 degrees. Okay? However, it's on second quadrant, the x value is going to be negative. In other words, cosine will be negative. So I'm going to put a negative sign in front. And now look at my table. Sine of 45 degrees, sine of 45 degrees is root 2 over 2. So this is equal to root 2 over 2. What about this one? Cosine of 45 degrees is right here, root 2 over 2 with a negative sign in front. So negative root 2 over 2. Okay? And with that table, very much you can take care of many of the problems that we have in the outputs. Okay? There's the next section is 2.3. I claim that this is a very simple, very short section. They just showed you how to plug the angle into the calculator and give the decimal approximation of the answer. So I will leave that section for you guys to read because I don't know what kind of calculator you have. In here I got TI-84, so pretty much the same, similar, and it's not much of a deal. If you have any question or you find difficulty using the calculator, please email and ask me. The only thing that I'm concerned is later on we're going to learn something called the radian, not just degree. Okay, there are 2 units, 2 ways to measure the angles. For now we have degree only, but later on we're going to have radian. So make sure that you convert your setup of your calculator into degree before you look in. Alright, and if you work with radian, of course you have to convert it back to radian in your calculator. And thank you for watching. Hopefully the short section today was helpful for your learning. If you have any question, again, don't hesitate to ask, please. Thank you.